This question is about the horizontal projectile motion, in which it says that a diver who jumps from a vertical cliff with speed v and it lands at some distance d away from the cliff. So for simplicity, let's assume or let's resemble the diver with this object, the ball, let's say, which we have thrown with some velocity, but remember that this velocity is v, that is horizontal, along the horizontal, which clearly means that this object doesn't have any velocity along y-axis, right? So we can say that its velocity along y-axis is 0, and according to the question, what will happen, it will land in the water at how much distance, at the distance d away from the cliff. Whereas how much vertical distance this diver has covered, let's say the distance covered is capital H. Now the question is, if the same diver or if we throw the same object with a double velocity, with the twice velocity 2v, then how far this ball will fall into the water. So let's solve this question. As I said that this question is about horizontal projectile motion, and what is the initial velocity? This is our initial velocity, and this velocity is responsible to take the object horizontally. All right. So if we analyze this motion, all right, we know that how much is the horizontal distance covered, that is d. So because you know that this is a constantly accelerated motion, that is a free fall, acceleration due to gravity is this. So why not we apply the equation, kinematics equation? So that is the equation for the horizontal motion will be this one: initial velocity multiplied by time plus 1 over 2 acceleration along x-axis times square. Okay, this is one of the kinematics equation. We know that there's a no acceleration along x-axis because we are ignoring the presence of air resistance, so due to which the force along x-axis is 0 and the velocity along x-axis will remain constant, means that even at this point, just before hitting the water surface, it is still v along the horizontal. Okay, let's put the values here. What is the displacement covered horizontally? uh, Not means from the base. So from the base it has covered d. So I can say d is equals to v multiplied by time, t plus 1 over 2 into 0. That is actually, this is our equation with which we can describe d, that this is the v multiplied by time t. Okay, now when we will throw an object with a velocity 2v, will it cover the twice distance? No, we have to figure it out. Okay, remember that it has covered the same vertical distance. So this distance covered d does not only depend upon the velocity but also on the time. And here I tell you that the time will not change even if you throw it with 20v. And why time will not change? Because time is affected by the vertically covered displacement. Okay, I explain you with the help of equation. So our equation is the, once again, a kinematics equation, or you can say the final displacement is equals to the initial displacement plus the initial velocity times t plus 1 over 2 acceleration along y-axis times t square. So this is one of the kinematics equation. So when we have thrown a ball, in both cases, in both scenarios, when it finally landed, so when it finally landed at this point or at this point, what is the final vertical displacement covered? That is 0 because that is at the ground. And what was the initial position? Initial position was a height h according to the diagram, plus what is the initial velocity along y-axis? Do you remember I told you the initial velocity along the y-axis is 0. This is initial velocity. So let's make it 0, and plus 1 over 2 acceleration due to gravity is negative g into t square. You can take the h on the other side, and negative h is equals to negative 1 over 2 gt square. By rearranging it, dear students, that is the equation for the time. And in both diagrams, since vertical displacement has not changed, that's why the time will not affect the horizontal covered displacement. Okay, so it means that this displacement must be equals to v, since it is 2v times d, so it means it is equals to 2d. So dear students, the right answer is 2d, but might be you will be thinking that what will be the effect of this double velocity. It will in fact increase the energy as well as instantaneous velocity at all the positions in the journey. Okay, so I hope you understand the question.